So let me start by saying it's great to be here. Great to talk to such a wonderful audience as yourself. So the topic, universal login. I give you 2 quick slides of background. So what I do is I run a one-stop shop for a blockchain project. We do a concept designs, DApp, smart contract development, recently formal verification, custom blockchains, and bridges. And we are lucky to work for some of the great brands in our space, and we are lucky to work for some great brands outside the blockchain space. And as we did, many times we encountered the same problems. It's really hard to onboard users to Ethereum, especially newbie users. And you might not remember that anymore because you buy your Ethereum a while ago, you buy your crypto a long ago, and now you're just switching back and forth between different currencies. But, and I'm not making this up, this is from the real tutorial you can find on the internet. This is 17 steps you need to take to buy Ethereum. And it's not very different for any other currency, and it's not very different from any other tutorial you can see on the web. So, ready? Here we go. So I need to choose a wallet. I'm gonna choose a MetaMask because I wanna buy some Cryptokitties later, and MetaMask happens to be the only wallet that I can do it with. I'm gonna save a keystore file because I know I need to back up because it's a good practice and everybody tells me I should do so. And I'm gonna store it in a very safe place, perhaps a drawer, because drawer is the right place to store all your money. I'm gonna open a wallet and I'm gonna copy a wallet address for using later. Boom, I go to exchange, I pick the exchange, I'm gonna use Coinbase. I need to register. I need to set up 2-factor authentication because I'm aware of the security issues. So I want to be on the safe side. I'm going to verify my account, and I'm going to upload my ID to go through KYC. And then I finally can deposit some money and buy Ether. Almost there. I still need to confirm. I still need to send Ether to my wallet. Boom, once it's on my wallet, not yet. I need to confirm with 2-factor authentication. That I want to do a transfer, and I can finally go to Etherscan and keep refreshing Etherscan until I see the transaction went through, and so I can go to Cryptokitties and start buying and selling. So the problem is two-parter. One part of the problem is usability. It's really a complex software ecosystem with multiple steps that we need users to learn. We need to use exchanges. We need to learn people how to use exchanges and multiple steps they need to go through. And we need to ask users to install plugins, learn wallets, and so on. But even then, even if we ask users to learn all the 17 steps, we still end up with not so good security because we still have seed phrases that we need to back up, or we need to order hardware wallets that we still need to store somewhere. And one could say we could use a multi-sig wallets, but the problem with multi-sig wallets, they are still pretty hard to use as of today. So the solution we would like to propose is building something that is already familiar with the users, something like Web 2.0 experience that people already know and use every day. And that's where universal login comes in. So in ideal flow, I just pick up the name. Boom, I'm already registered, I can start using application. And here is a quick screencast from the demo application we built last year and to show on DEF CON. Here we go. Boom, I'm already onboarded. So what happened? To explain that, I have to explain you what universal login is all about. So universal login is 3 technical concepts. First technical concept is we build personal multi-sig wallet. So everything we do with a smart contract that is deployed. It stores all the balance and do all the interaction with the blockchain. Second concept is meta transaction. So meta transaction enable a bunch of different usability features, and most important one is ability to interact with the smart contract without having any Ether on the different keys that I store on the different devices. So the only balance, the only Ether balance, or the only token balance that I need to store is I store on the wallet itself, on the smart contract. And finally, universal login itself is ability to give a name to a wallet I created and use that name to log into different services, give them their own keys, and give them ability to interact with my money, with my confirmation. So here is a second part of the presentation. I'm gonna use another application. So let's say on the left, there is a mobile application. I'm using the same name, but now it already exists, so I can connect and confirm from the first device, and boom, I can start interacting with the application from both of the devices. So, and here is the summary of the flow. We just go there, and if the account already exists, I can use the other device to confirm that I want to connect this particular device, this particular application to my contract wallet. And one more technical summary. So we have a wallet contract in the middle. We have a bunch of different keys that are on bunch of different devices, and we have a relayer that helps us relay transactions. So we sign a transaction using the key, relay to relayer, relayer wraps it into Ethereum transaction, push it to the wallet, push it to the blockchain, to the wallet contract, and boom, transaction happens. On the technological side, the stack looks like this. We have smart contracts as the heart of the system. We have a relayer, which is JSON RPC server that provides JSON RPC API. And we have a JavaScript SDK that allows you to easily communicate through the relayer with the smart contracts. On top of that, there is a demo application that you just saw. Good. Are you ready for some coding? Any questions so far? Oh, yeah. Someone's very excited. Excellent. So I'm going to show you how in 15 minutes, let me just grab something to drink. So in 15 minutes, we're going to create a new application. We're going to create a development environment. And we're going to create a wallet and relay some transactions through it. Are you ready? Good. I'm going to need to do, OK. I'm going to delay it a little bit further. I need to attach microphone now. Make sure you're going to still hear me. Not so easy. Well, how do I do that? Any expert on microphones here? OK. I think that should do. Good. Can you hear me? Can you hear me? Wonderful. So let me go to my development environment. Where is it? Where is it? OK. Can you see it? Can you see it? Good. As you see, I have an empty catalog. Let me start with an empty catalog. And we're going to create a new application. Can you see the font size is fine? Can you see it? Should I enlarge it a little bit? Let me do that. Is it better now? OK. Scream if it's still too small. So you can see application is empty, and I'm going to create a new application called ETH Denver. Just going to use all the defaults, and I'm going to add a package that is called UniversalLogins SDK. Good. So that's going to install. That's going to be pretty fast. And on top of that, I'm going to add another package, and it's going to be a development dependency, and it's going to be called UniversalLogins Ops from operations. It's going to take a little bit longer to install, and what this package does, it creates development environment that runs mock blockchain, Ganache for you, deploys CNS, deploys a couple of test domains, deploys a mock token, and allows you really easy, quick start, quick jump into application. Now, it's going to take a moment to install, and there's going to be one problem that I wanted to show you, so you know if you decided to hack around with it. So the Ops project has a dependency on Ganache. Ganache has dependency on Web3, and Web3 doesn't work for a couple versions in a row. And there is a way to force package JSON to use particular version. OK, don't save. So this is how it looks like now. And if we Yeah, we're gonna add 2 scripts. Before doing that, we're gonna do like this. So we're gonna have a start script that basically gonna start our application. Easy peasy. And we're gonna have start dev script that's gonna start development environment. So it's gonna do universal login start dev. Bam. And I would like to tell you that that when I do this, it's gonna work, but it ain't gonna. And the reason is exactly what I told you in a moment. So what I need to do is I need to add resolution section in my package.json, and I'm gonna say web3 is gonna be 1010 beta 35, which happens to be the kind of last semi-working version. Did I make a mistake or something? Let's see. Yarn. Okay, resolving. Okay, we can use that time to create a new file, which is gonna be start.js. Good, and we're gonna just console log something for now. Heal. Good. We have. We can now run dev environment. Boom. You can see Ganache is up and running, ENS deployed, token contract deployed, relayer has been started, and I can do now yarn start, which is gonna run our. I think I need to increase the size. Yarn start that's gonna run our application. Boom. Good. So what we want to do is we want to create an instance of SDK. So we're gonna import that. So note we're gonna write in pure JavaScript. You can use TypeScript if you prefer. You can use ES6. Well, it's gonna be ES6 actually. SDK, and we're gonna require. It's really hard typing here, you know. Can we have some help here? So login SDK. There's gonna be some ugliness to that, so we're gonna add that default here. And once we do that, we can create an SDK itself. So we say new UniversalLogin SDK, and it's gonna take 2 parameters. And the first parameter is gonna be address of the relayer, and we have a relayer over here on port 331. So HTTP localhost and the port number. And the second one is gonna be Ethereum node. So very similar, just a different port. So I'm gonna copy paste that. Whoop, too fast. And the port number is here, 18545. Good. And now that I have an SDK, what I can do is I can create a contract. Now creating a contract is super easy. All I need to do is do create and tell how I would like to name my wallet contract. And there is already domain registered, my login ETH. And there is just one thing I have to remember about. It's a function that returns promise. So I'm gonna need to package that. So async function create wallet, and that's pretty much it. Now this function returns two values. One is the private key. So it's going to be a new private key created for this particular device. And the second one is going to be a wallet address. And what I'm going to do is I'm simply going to display both. So we have private key, and we have wallet address. Now, to run it properly, we're going to need to, well, call the function. Create wallet, and we will need to provide SDK. And what we're also going to need to do is make sure that if error shows up, we're going to display it. Boom. Let's see if it works. Boom. I just created a multi-sig personal wallet, and there is a private key. So what I'm going to do is I'm going to save those values to use for later. So we're going to have private key. And the private key is the first value, so I'm going to copy-paste it. And by the way, we are now 5 minutes into coding, and we already created a wallet. Try to do it with Web3. And I'm going to also store contract address. So, and by the way, if I try to run again, it's going to fail. And the reason is that the name is already reserved, so I cannot create the same name again, right? But what I can do is I can try to transfer some Ether. So we're going to write a function, transfer Ether, that's going to transfer some value from the wallet to anywhere else. And before I do that, I'm going to display the balance of my contract. See how much Ether do I have. So SDK has a provider, and provider has a getBalance function. And by the way, it returns promise. So all I need to do is ask the function and display the results. And here we go, and we're going to ask this. We're going to call this function this time. So that's a contract address, wallet address. We can use it as a synonymous. Bam. OK, not very readable, so let's to string. And you can see there is some balance, and the reason is that we already have that the development environment already put some test Ether on our contract so we can play around. So, OK. I'm going to now try to transfer that somewhere. So what I'm going to do is I'm going to call execute function. And it takes 2 arguments. Private key is the first one, and the message is the second one. Now, what's a message? Message is very similar to Ethereum transaction. So it has a to, it has a value, so let's say just one pay for now. It has a from, but from, this is interesting, from is actually our contract address. And it has one additional parameter that you probably never seen before, which is gas token. So Relier gonna pay for us, and we have to tell him what is the token that we would like to pay. And we're gonna use a token that was already deployed. We can do it with Ether. We just provide 0x0000 address. But let's make it more interesting. As you could see before, we had this, as I mentioned before, we have this gas token deployed. Well, that can be any ERC20 token that Relier supports. And bam, gas token is here. We also need a to address. So I propose we're going to use just 000, but we ain't going to use, I want to get the right number of zeros. We're going to use 00001, because 000 is a little bit tricky, and oftentimes there is more than you expect there. And let's see if it works. OK, I think there is some, yeah. So let's do that. And whoop. Let's do like this and see if it works. Something more. Invalid argument to verify. Anybody see what that might be? Balance to string, execute private key message. Perhaps it's the other way around. I'm not sure anymore. Okay, good. And that needs a wait to work, right? Because otherwise it's gonna boom. And you can see that one was transferred. Actually, I transferred twice, in the first and the second transaction, because development environment is the same, right? So there was no await in the first example. Now there is a wait, so we do 2 transfers. So I can look at the time and tell you that we are 15 minutes into presentation and we already did some transfer, use meta transactions, deploy a wallet. So it seems like we're doing pretty good. So I think we can stretch it and try to transfer token. Token is traditionally a little bit more complicated. So I'm going to create a new function, and it's going to be called transfer token. But before I do, I'm going to create a function get token balance. So we can see what the balance of the token is of our contract before we actually, so it's going to be need to be a function, await get token balance, and we're going to see what is the token balance for the contract address. Okay. Now this is where it's oftentimes get a little bit more trickier because now we have to interact in between multiple contracts, but I think we can tackle it just fine. So all we need to do is have a token contract. And what we want to do is we're going to call balance of. So let's say this is address that we want to see the balance of. And that's going to be a balance. And we're just going to display it. Now the problem is we need this token contract. So that introduces a bunch of new things. So we're going to need to have a contract abstraction, and we use Ethers as a default provider. So we're going to need that, and we're going to need an API for the token. So we're going to require that from UniversalLogin ops projects. And we're going to need to create an instance. And the funny thing is we can do it here as a const because we have all that we need as const, right? So that's going to be a new Ethers contract. And the first argument, if I remember correctly, is the address, so gas token. The second argument is the API, so token interface. And the last is provider, so SDK provider. And if we are successful, we should be able to display token balance of our contract. Are we successful? Yeah, there's a typo here, UniversalLogin. Do you follow me? Can you find typos? Can you see when I'm wrong? Boom, again, not very readable, so we're gonna, okay, good. So you can see the balance. There is some token balance on the wallet, but it already been subtracted multiple times because we pay with the token for all the transactions, because Relayer pays for our transactions and get the refund from the contract in this token. And the reason why it gets in this token is because we told him to. So we're doing really well. So why not push it some further, and we're gonna, yeah, let's just copy that and see if we can transfer a token. So we're still transferring token to the same address. Now value is 0 because we're, well, sorry, actually 2 is now what? Who can tell me what the 2 should be now? Anyone? I can hear. Token smart contract, did you say? Yeah, so we're now doing a transaction to to a token smart contract, which happens to be gas token as well. We're still doing from the same contract. We're still going to pay with the same token, but we also need to create a data. Now, data is the encoded call to the function transfer of ERC20. So, data equals, that's going to be a tough one. So we're going to need to take the interface of token contract and from its functions pick the transfer function and encode, and we're going to need to give parameters. And if you remember, transfer ERC20 token transfer have two parameters. Who remembers what are the parameters? So the first is 2, and the second is amount. So 2 didn't change, and amount, let's do 7 this time instead of 1. So let's see what's going to, so that's 7-way token. No, okay, so there is a typo, gas token. Where is gat token? Gat token, yeah, okay, so here it is. Good. I think we're now spend like 15 minutes setting the project, setting the SDK, doing Ether transfer, doing a token transfer, and we did it all under 50 lines. So I think that pretty much gives, oh, someone is like clapping. Thank you. Okay, some of you are impressed. Good. We can do it again, so we can see I'm not cheating. We can also see what is the token balance of 2. So we can see it's really transferred. It's not only subtracted or anything. Good? Good, 21. Good. Yeah, I think we will go now to the presentation. So I just want to say, if you ever would like to bring it to the testnets, it's really easy. There is you just need to change the gas token address, and you're also going to need to change this address and that address. And at any point of time, you can go to our documentation, and it's all there. So it's going to take another 3 minutes, but I think we're running out of time, so I want to take those 3 minutes. Good. So I'm super happy to tell you we got a lot of traction. We started project last year. There is a bunch of projects already building on top of that, even that we are still early stage. A bunch of projects that were inspired by our work. We're doing a lot to promote it, even though it's not production ready, and I think we need a couple more months to get to production. We're promoting it, we're showing what we're building, so you get the idea. We build this development environment so you can hack with it and give us feedback and see how it works. The important thing is what we're building is open source. It's open. We try to standardize it so anyone can build on top of that. Anyone can build his own implementation. Anyone can integrate that into his own product. On the technological stack, as some of you probably noticed, we're using Ethers.js. On top of that, we build a library called Waffle that is already getting pretty popular, which is a testing library for smart contracts built on top of Ethers. Built on top of Ethers.js. And I'm super happy to tell you that 1 month ago we started our efforts with formal verification, so we can formally verify our work to make sure that there are any bugs that might lead into losing money by someone in the future. And I would like to say special thanks to Alex, who's been working with us all the way through on it. Alex van de Sande was also the person who originally came with the concept. And I would like to thank Etherprise and Ethereum Community Fund, which funded a lot of development effort last year. If you would like to learn more, go to UniversalLogin.io, go to our GitHub, and we would love to see you contributing. We would love to see you hacking, and I'll be sticking around for the next 3 days, today and another 2 days, and would love to help you. If you have a project that you would like to use to try it out, that's lovely. If you don't have idea, we have some idea what we could be, how a wallet could be built in top of Universal Login, and we would love to build a team if we see people interested in doing so. So, and follow me on Twitter if you would like to get updates on the topic. And I think we still have a couple minutes, so if there are any questions, I would love to answer. Does anyone have any questions? Questions, questions, questions? Good. Oh yeah, there are 2 questions over there. Can I ask you, sir, to come up to the mic and ask a question?
So when you send in the transaction and you specify token address, and that's under the assumption that there are some money available, and
yes.
that's usually who puts the money? Is it the user or is it the dApp?
Sure, so it's a very good question. So the development environment already deploys a token and puts some development ether and puts some development token onto the contract. Of course, in real life, you have to transfer the money first to be able to do anything. But we imagine there are some use cases that if you get verified, you can get some free tokens as an incentive to start doing things. And those first tokens can pay for the very first transactions that you want to do. So, or imagine you have an ICO tokens that you get and you don't have any ether. You can actually start using them right away. Okay? Following a question.
In that case, I guess in the very beginning,
okay,
so
two more questions.
As a dApp developer, in the first time user ever on board, because they don't have token or anything, so you point to some generic contra where the dApp provider kind of puts some money, but once something happens and the users start getting, you, as a design pattern, you have to point to user-specific contract which has user's own funding.
Yeah, I'm not sure if I follow the question, but every user have his own contract. Does that answer the question or not?
Yeah. Otherwise, like people keep depending on you.
No. Everybody has his own contract.
Yeah.
And as you know,
okay.
as you know, we're working on counterfactual deployment, so that actually the contract is deployed only once the funds are already there. I think there was one more question. Did you, sir, have a question? Okay. Okay, one more question. Anyone has last one question? If there are no further questions, well, thank you very much.